All right. So like basically just these problems just they encompass the cross section, which is like the different areas, arc length and then surface area. So I don't want to like write every single formula, but I'll write the formulas for example, like for the ones that are on the review. I'm not gonna do the first one because oops. I'm not gonna do the first one because that's it says cross sections that are squares and the squares are kind of easy because you know that a square's area is just base times height, so it's just the base squared. But the others are like a little bit harder to remember. Um so remember that you need to know like the base and then the area. And then the final answer, the volume V, the volume is equal to the integral of the area. So like you're kind of doing three different things. Like you get to get this first, and then you get to this, and then you get to that. So the base, I know it's kind of weird to think about it, but she just describes the base as like either being high, low, or right, left. So when you graph something on a graph, the one that's high, and then the one that's low, you just do the high minus the low, and that'll be your base for every single problem. Um, it's the area where it becomes unique to like the shape that it's asking. So like equilateral triangles, that's its own formula. The one on the bottom is semicircles, that's its own formula, and then the squares is its own formula. So um, I'll write it for just those three shapes, but actually I'll write it as we go on. So the area for the equilateral triangles is radical 3/4 base squared. So the first thing that I'm gonna do, and this is the first thing I recommend you do for these three types of problems, the only one that you really have to graph are the cross-section ones. For arc length and for surface area, you don't really need to graph it to solve it. But when you graph this one, it'll be fairly easy to see like, you know, what your bounds are. So you'll notice that for this one at least. Um, when you graph it, you see that oh, and an important thing to note, it says perpendicular to the y-axis. So actually the first thing I did in my work before graphing it was I changed the y is equal to x squared just in terms of y. So it just becomes x is equal to y to the 1/2. When you're doing things like perpendicular to the y-axis, like when your reference point is the y-axis, you want like your equation in terms of y and everything equal to just like 1x. So I just wrote that down, and as soon as you do that, then you can graph it. So I graphed it on the side. This graph over here is the same as this. So when I graph it, I just did like 1, 2, 3, 4, 1, 2, 3, 4, and then that's 1, 1. You know that when it's 2, it's 2, 4, and it kind of goes like that. And it's telling you it wants it from x is equal to 2 and y is equal to 0. So like those are other like little points you can plot. So x is equal to 2 is this line over here, and then the y is equal to 0 is the y-axis. So like the shaded region you're looking for is there. Does that make sense?
Mm-hmm. Yeah.
Okay, so then at this point, now you're just kind of figuring out the base and then the area. So like at first glance, and I guess like this problem could be solved much easier if you're doing it perpendicular to the x-axis, but it's asking for the y-axis, so keep that in mind. Remember that y is right left. So let me erase because I'm taking up a lot of space. So the base would be right left. The right is the line x is equal to 2, so it's 2. Your left is like this line over here, so that's really just y to the 1/2. And then your area is, and remember the area of the equilateral triangles is radical 3/4 base squared. So just like keep that formula in mind. The area, I'm gonna erase. So the area, the air conditioner turned on and the papers are blowing away. Okay, the area is radical 3/4 base squared. This is the base, so you're just doing this squared. Yeah, I'm just gonna write a radical because it's easier to do it that way. So you do have to expand that out, but it's not too bad. So I would just leave the radical 3 over 4 here. Don't like distribute it. When you expand this, it's 4 minus 4 radical y plus y. Do you understand what I did? Or like, do you guys like FOIL it out when you do something like that?
Yeah. Mm-hmm.
Okay. Like basically, like the easy way to do it is just you square this, you square that, and then you do 2 times this times that. So 2 times negative radical y is negative 2 radical y times 2 is negative 4 radical y, and that's your middle term. So now that we have the area, this is the area. Now all we have to do is find the volume. And remember, the volume is the integral of the area. So I'm going to erase the top now because we're kind of done with that part. So now all we have to do is just integrate that kind of long expression. So v is equal to the integral. You need to know the bounds, of course. So if you go back to the little graph that we drew, it kind of looked like this. Remember, 0, that's 2. Remember that we're doing everything in terms of y's. So if we were doing things in terms of x's, our bounds would be 0 and 2. But that's not the case. We're doing it in terms of y. So you need to know that this graph stops at y is equal to 4 and it starts at 0, 2. Because when x is equal to 2, it's equal to 4. It's kind of easy to picture. So the bounds are 0 to 4. And then we just plug in the area that we got. So radical 3 over 4, 4 minus, I'm going to erase some of this. 4 minus, sorry about that. 4 radical y plus y. dy. Don't forget the dy. She's going to take off points. So then now I would just say move that radical 3 over 4 on the outside. If there's any number that's like kind of there and like your first thought is to distribute it, don't do that. Just move it in the front and deal with it later. That's what I highly recommend. And then really you're just kind of integrating this expression. So this is going to be I'm going to change it back to the 1/2 because it's easier to integrate that way. And yeah, this is just regular integration. Hopefully like you guys know how to do this, but any one of you just like tell me how, like what you guys get when you integrate this, just so like we can make sure. So like go term by term. Anyone?
I'm doing it. I just worked well.
You don't have to write it first. You can just say it out loud.
Would it be, wait, okay. 4x
For
minus,
4x?
wait. 4y. I'm sorry. Yeah, 4y.
4y.
Yeah, it's just my instinct is in.
Yeah. Next one. Well, like you don't have to do it right away. And like what I'll tell you is that I don't like get the simplified version right away. I keep the 4 in the front. I know that you have to add 1 to the exponent. So your new exponent is 3 over y to the 3 over 2, right?
Yeah. So
And then you have to divide by 3 over 2. So you multiply by 2 times 2 over 3. And I just leave it like that for now. Like I'll do the simplifying in the next step. I don't want to do too many steps in one thing because then I make a mistake and then the whole answer becomes wrong. And then the last one is just y squared over 2. And then I don't know if I have enough space to draw the line, but it's from 0 to 4.
Oh, yeah.
So then the next step over here, it really is just plugging things in. So and this one is kind of easy because when you plug in a 0, everything, that whole expression becomes 0, so you don't have to worry about subtracting something else. So when you plug things in, and this is something that maybe is not smart to do, but I just plug it in my head and write the answer. So like we're gonna start with 4. So like I guess it would be smarter to do 4 parentheses 4, but I just do that in my head and write the answer. So when you do that, you get 16. Remember that it's 4 times 2/3, so I'm gonna write 8/3 in the front, and you're plugging in a 4 to the 3/2. So I am not gonna do that right away. I'm just gonna write 4 to the 3/2, just because that one does require some more thought at like first glance. And the last one is y squared over 2, which is 4 squared over 2, 16 over 2. That is just 8. Minus 0. Remember that. You don't have to write it, but like really it's supposed to be minus, as if you're plugging in this one into everything. But since it's going to be 0, I just write minus 0 just like for that clarity. So now it's really just about fixing this and getting an answer essentially. So I'm going to erase the top when I run out of room. So radical 3 over 4. I'm going to combine these two right now. That's 24.
Hello?
So 8
Yeah.
over 3. Natalie, you're not on mute. Okay. All right. So and maybe you guys like I don't know. Kate, tell me if like you do know, like, do you know how to represent 4 to the 3 halves like in other ways, or like that you usually use a calculator to solve that?
It's tricky for me to do that part.
Okay, so I'll give you like a little shortcut. So and it's like life changing. If you're confused, just remember that this, if you have an exponent, it's really like you're multiplying 4 to the 3 times 1/2. Does that kind of make sense? Because this is like the same expression.
Yeah.
Remember that when like there's exponent in parentheses and then there's another one on the outside, if you just multiply them, you get the same thing. 3 times 1/2 is 3 over 2. It's the same thing. The same thing can go the other side. So squiggly 4 to the 1/2 times 3. So my like piece of advice is do whatever's easier. If it's easier for you to do 4 cubed and then take the square root of that, do that first.
Oh, okay, I get it.
Easier for you to do the square root of 4 and then cubed, do that. I think the second way is easier because the square root of 4 is just 2 and then you cube it, it's 8. And that's the answer.
It's easier.
Does that make sense?
Yeah, it's easier for me to take the square root first and then go from there.
And then just remember that like when you're dealing with like exponents like that, like an odd, like the 3 over 2, 5 over 2 or something like that, kind of split it up and then choose whichever method is easier. Like that's like the easiest way to get the answer without a calculator.
Yeah, no, that definitely made it
I know
easy.
like we didn't really kind of learn that. I actually learned that from I never learned how to do that until Miss Q. So so yeah, I'm gonna write this as 4 to the 1/2 to the 3rd. And then at that point it's kind of just like simplifying the rest. So I'm gonna erase the top part of our work and finish it up. Because there's like no room on this paper. Yeah, so I'll continue. I'll do it in black. So radical 3 over 4, you have 24 minus 8 over 3. 4 square, the square root of 4 is 2, cubed is 8. So that's 8. Radical 3 over 4. Remember, this is all equal to the volume. 24 minus, that ends up being 64 over 3. Because you're doing 8 times 8. The next step would be, there are 2 things you could do. What I would recommend you do, this is what I did in my work at least. Just trying to like try to make the parentheses into one fraction, like combine the like terms. So radical 3 over 4, 24, in order to subtract them, you need to have a denominator of 3. So you multiply by 3 over 3. 24 times 3 is 72 over 3 minus 64 over 3. That's simply 8 over 3. And when you multiply those two together, you can cancel these. So this is 2, that's a 1. And the final answer is really, and this is the way she wrote it. She wrote it as 2 radical 3 over 3. And that's the answer.
Okay.
Yeah, so that one was, I would say the hardest thing is just getting the right answer from the area and the base. Integrating it is not like the hardest part. So yeah, Natalie, do you understand? I know you had to like pick. Okay, yeah.
Sorry, my mom had called, but I've been here.
No, you're good, don't worry. All right, so I'll go to number 3 now, unless you like are confident with like just like this concept altogether and like you'd rather we do arc length and surface area.
So the only, wait, I need first of all for number 3, the formula for semicircle.
Oh yeah, like so here, like instead of doing the whole thing, I'll kind of set it up. So and this number 3 is like the hardest one because whenever it asks you to make things into y's, it's a little bit harder because you want to make sure you're doing it right. We usually work with x's and y's are a little bit different, even though they're kind of the same. So it says oh, let me move to that question. The base of the solid is revolved around the region enclosed by the graphs of y is equal to radical x and y is equal to 1/8 x squared, y-axis, and cross sections that are semicircles. So there, you can either start by graphing it or by converting it into y's. The first problem that we just did, I converted it to y's first, but like I would say graph it first only because you can graph it with this. And I personally think it's easier to graph when you have things in terms of x's. Even if you convert this to y, so let's convert it to y's. This becomes x equal to y squared. This one over here. And this one over here, y is equal to 1/8 x squared. This becomes 8y x squared. And then your x becomes the square root of 8y. I think it's easier to graph with these two equations than the new two equations that you got, this one and that one, just because like you have to remind yourself like you're plugging in a y value and you're getting an x value instead of what we've been doing our entire lives, plugging in an x value and getting a y value. So when you graph these, 1, 2, 3, 4, 1, 2, 3, 4. So when you graph that, I'll do this one first. Y is equal to radical x, 1 comma 1. The next one I know is when you plug in 4, you get 2 as your y. So it looks something like that. And then the next one, 1/8 x squared, I'll plug in 1. So when you plug in 1, you get like 1/8. So like that's like kind of there. When you plug in 2, you get 1/2, 4/8. So that's like in the middle. And then I'm not gonna do 3 because you get 9/8, and that's like a weird number to work with. But when you plug in 4, you get 16/8, which is 2, which is right over here, and that's what it looks like. So you know that your shaded region, or like the region you're really trying to find, is like this one over here. So and now it's easy to see which one is the high and which one is the low, or in other terms, since we're doing y's, it's easy to see which one is the right and which one is the left. The right would be this green one. So that one is x is equal to radical 8y. And the left is, I'll do it in red, this one, x is equal to y squared. So now let's kind of set up the base, and I'll do the area. I'm not going to do the integral, but I'll do the area because it requires more thought. So yeah, let me erase this and I'll set up the base. So your base, that's the first thing you do. Your base is just right minus left. So radical 8y minus y squared. Easy enough. Now, the next thing that you have to worry about is the area. So it's saying that the cross sections are semicircles. So the area of a semicircle is pi r squared over 2. And they define r as your base over 2. So really, the formula that we're going to be using are right at the bottom. Over 2. Kind of, which is pi base squared over 4 over 2. And then frankly what I would do is just make this like pi over 8 over base squared, because like it's just too many numbers, like like you have a fraction over a fraction, and that's like really complicated. So it really is just pi over 8b squared. So let's just now plug in the base. So keep this base in mind, because and keep your graph in mind. Like try to graph it, just because Ms. Q likes to see the graph, and because I'm gonna erase it. Oops. No, I only wanted to erase the top part for now. So after all that manipulation, I got that the formula for the area of a semicircle, and let me know if I lose one of you. Just make sure that I'm not confusing you guys. Pi over 8 base squared. It's pi over 8. The base is radical 8y minus y squared. And yeah, all we have to do is square that. So I'm gonna erase this now. Ooh. I'm gonna erase this now and actually solve it. So again, this is just practicing like with binomials. It's 8y, that's y to the 4th, and the middle number, this is the one where I was like, it was kind of tricky. So really what you have is like negative 2 radical 8y y squared. Does that make sense? Or not
Yeah.
really? Okay, so like that's the first step. But like, I'm gonna be honest with you guys, like when you see that number, because this is like what we have here is what we're gonna be plugging into the integral, right?
Yeah.
This is easy to integrate, that's easy to integrate, but like would y'all know how to integrate that? That's like kind of weird. Like I'd want the y to be with the y and the numbers to be with the numbers. So I'm gonna fix this so that it looks better. If that makes sense. So
Isn't it
pi over 8
plus y to the 4th?
8y.
Oh yeah, wouldn't it be plus y squared? I mean y to the
No, I'm
4th?
not. Yes, plus y to the 4th. And now did you say like y to the 5th something, or was I hearing
No, I
things?
said wouldn't it be plus y to the 4th?
Oh yeah, it is plus y to the 4th. Thank you. Now I would say the next step is to just work with this number over here. So actually what I'm gonna do, just so that I'm not rewriting all these irrelevant numbers that we're not dealing with right now, I'm just gonna clear this and focus on how you guys can simplify that number. So it's negative, let me change the color. It's negative, and the number that we had was negative 8 radical y to the 1/2. The first thing I did was I kind of split this up because when you have two numbers inside a radical, it's the same thing. So radical 8y.
Squared?
Wait,
Wasn't it y
it was.
squared?
I think it was y squared. This known. Yeah. Sorry. I'm kind of just BSing it. All right. So this is y squared, and the first thing I did was I just split up radical 8 and radical y. And you guys know that I'm gonna deal with the radical 8 later. But radical y is really y to the 1/2 times y squared, and that number over here is y to the 5/2, because y squared is really, or can be represented as 4/2, and you know that when you have two bases and you're multiplying them, you can just add the exponent. So it's really y to the 5/2. And yeah, I mean, you could leave it as negative 2 radical 8, but I like to keep things in like simplest, like lowest radical terms, and you'll notice that the answer is in lowest radical terms. So you definitely want to deal with like lower radicals. So really, this is just radical 4 times radical 2 y to the 5/2, which is negative 4 radical 2 y to the 5/2. And that number is just, it's still kind of complicated, but at least it's integrable. And you guys know that the radical 2 is just like a number in the front. So like you don't really do anything with it. It's just like a coefficient. So kind of treat it as such. And yeah, I mean, then I'll write the final area that you would be working with, but the final area that you'd be integrating is pi over 8. Remember to leave that number in the front so you can just put it in front of the integral. 8y. I'm gonna plug in this number right over here. So it was 4 radical 2 y to the 5/2, and then the last one was y to the 4th. So that's what you'd be integrating. And just like let me know if you have like a problem integrating that number. But I want to do an arc length one. So I'm gonna do, because it's already 5:30, so I'm actually gonna go right to 6 and 7 because they're also arc length, but they're like kind of weird, I would say. Um, and the regular number 4 and 5 are just like regular arc length problems. So if you know to do like the harder one, like you'll know to do those. So this particular problem, and it goes hand in hand with number 7. It's like the same base. So it's telling you to use the arc length formula in a calculator. So for this one, you don't have to do like the integrating by hand. You can just plug the equation x squared plus y squared is equal to 4, which you guys know is a circle. And it's telling you that they want to know the arc length from point 0, 2 clockwise to point radical 3, 1. So the first thing I did, because normally you don't need to see a graph to do arc length, but for this problem, I think it's helpful to see like what you're plotting, just because like you want to know like really what arc length you're getting, and especially when you go to number 7 and it says do it but now counterclockwise. That requires some more thought. So I just drew the circle itself. You know, this equation, it has a radius of 0, 0. Oh wait, no, sorry. It has a center of 0, 0. The radius is 2 because this over here is r squared, which is 2. So when you graph that, 1, 2, 1, 2, 1, 2, 1, 2. Your center's over here, and your circle itself is like this. Yeah, and that's how it would look. And it's telling you they want the point from 0, 2. So like I'll do that in green. This is that point, and it says radical 3, 1. Well, I know that radical 3 is like, you just need to find the point where the circle has a y value of 1. Radical 3 is like 1 point something. So that's like right over here because you're looking at that value. And basically it just wants the arc length of this. So this one is not as bad. So really, and I'll review the arc length formula. Remember, it's S is equal to, S is arc length, the integral from A to B. So it depends on what you're looking for. In this case, it would be from 0 to radical 3 because it's 0 to radical 3. And it's the square root of 1 plus the derivative of x, so f prime of x squared dx. That's the arc length formula. So the first thing that we need to do is find f, or y, because the equation itself that we're given is not in terms of y. So let's just do that first. Write down the formula and just make sure that you have it in mind. So really the best thing you can do in this scenario is just make things in terms of y. So you make this y squared is equal to 4 minus x squared. Then you take the square root. Remember that this is really plus or minus 4 minus x squared. This could be split up into 2 equations essentially. So the plus version, 4 minus x squared, is really this region over here, the yellow. And then when you do minus, it would be this region in red, this bottom half of the circle. And that's like how you split it up. Notice how the arc length that we're looking for is only on the top portion. So I'm just going to deal with this equation. Like this is irrelevant in this problem. So let me erase all that. So now we have to take the derivative of y is equal to radical 4 minus x squared because the formula requires f prime of x. Now once we have f prime of x, we can square that. There's a lot of many steps in these problems. I suggest you do them to the side first. Then when you get f prime of x squared, then you plug it in, and then you can just do the integral. So the derivative of this, I'm going to write it as 4 minus x squared to the 1/2. Remember that you just bring the 1/2 to the front. It's 4 minus x squared, and then you subtract by 1, so you have negative 1/2. Remember the chain rule. Since the derivative inside this little part here is not 1, you have to take the derivative inside there too. That's negative 2x, and then you stop. So the final derivative for this this equation is really, and I forgot to write y prime. It's really, you can cancel this 2 with that 2. It really ends up being negative x over 4 minus x squared. Does that make sense? Are you guys like both?
Yeah.
Okay, yeah. So now at this point, all you have to do is square it. So we just clear the room. And you can write the square as like this. So when you square it to the side, you can just write y prime squared. It's really just negative x over 4 minus x squared, and that's in a radical. So when you square that, you get x squared over 4 minus x squared. The radical cancels out, and the top just becomes x squared. So yeah, it's that simple, I guess. And then now all you have to do is plug it into the formula. And in this particular problem, she doesn't want us to solve it. She just wants us to set up the formula and use our calculator to solve it. So it shouldn't be too bad. So I'm gonna erase all of this for now. Great. And yeah, keep that number in mind. I write it here, but I want to start from the top of the page. So S is equal to the integral from 0 to radical 3 of radical 1 plus f prime of x squared. We just got it, so it's x over 4 minus x squared dx. At this point, I'll tell you guys that like you kind of just need to know how to manipulate it, because that's
Wait,
gonna
isn't
be
it x squared over 4 minus?
yes. Sorry. Yeah, thank you. And then at this point, I would say it's just about kind of knowing how to manipulate and go from where you are like at the moment. So, I'm trying to think of how to word it. So either you'll want to get rid of the 1, or the 1 will help you find like a perfect like square that you can kind of use. But in this particular problem, we're just going to get rid of the 1. And how do we get rid of the 1? Well, we want to combine this 1 with what we have over here. So 0 radical 3. In order to get rid of the 1, in order to combine these two numbers, they have to have the same denominator. So I'm just going to write this as 4 minus x squared over 4 minus x squared. You guys know that's 1 plus x squared over 4 minus x squared. At this point, you just combine the numerators and you leave the denominator. So 4 minus x squared stays. When you combine these, you just have a 4 on the top. In order to get the answer she had on the review, you can now split it up. You can do the square root of 4 over the square root of 4 minus x squared. That's the same thing as this term over here. So this is the same thing as that. And then finally, don't forget to write the dx. I've been forgetting, but don't forget. And finally, what you can write it as is the integral from 0 to radical 3 of 2 over radical 4 minus x squared dx. And at that point, honestly, like you could have just plugged from your calculator, like at this point over here, but the answer that she has like kind of involves some simplification. So yeah, like really you can just plug in this or that, but when you plug them in, you get a certain answer in your calculator. Do you guys remember how to do like the integral in your calculator or not really? Yeah or no?
Yeah, pretty sure.
Okay. Yeah, so just like remember that it's math 9 to get the integral like symbols, and then just like tell me what you guys get as the decimal. Remember to put that it's from 0 to radical 3. The number on the inside is 2 over radical 4 minus x squared, and then remember to write dx. So what's the answer that you guys get?
Okay, are you doing it right now?
Is she there?
I don't know. My
I
calculator.
didn't realize I was muted. I'm sorry. I thought I was unmuted. Is it 1.31695, that whole thing?
No.
Oh, and I don't know what I did.
Okay, wait, let me get my calculator for my book bag. Super quick.
Okay, so like you put math 9, right?
Yeah, I did.
And you put from 0 to radical 3.
Mm-hmm.
Maybe because like, do you guys know to put a fraction like in the calculator or no? You guys don't know to do that. Because
Maybe
I wrote it as a fraction. Like I put fraction symbol and then I put 2 bar 4 minus x squared, all in radical. And like,
maybe if I do it like that, it'll work better.
yeah, because if you're putting 2 divided by like 4, I don't know. I find that when you just write it like that, it definitely helps because the calculator like really needs like those specific commands to get the right thing.
Okay.
The fraction. Yeah, fraction, you could do math.
Yeah.
And then look at your like the arrows on the right where it's like the top arrow, the left arrow, the right arrow, and the bottom arrow. You click the left arrow where it goes frac, like for fraction.
Yeah.
And then you just put the one that says 1 and over D, or you can put enter, you can just put 1. And notice how like it sets it up for you.
Did you get 2.094?
Yes, that's the answer.
Okay, let me try it just to make sure.
Yeah, I know the command is like tricky, but like if you use it a lot, like it'll become easier.
I got the same answer again.
One last thing, is your calculator in radians or degrees?
How do I check? I forgot.
It should say it at the top. Like
Yeah,
real radian math or
it's in radian. Is it supposed to be in radian?
Yeah.
Okay, then I don't know what's wrong because I keep getting the same answer.
Time later. But yeah, that's essentially what you do. And as long as you have the right setup, it should be fine. So I'm gonna move on to number 7, just so that don't worry about like the answer part right now. Again, I can help you later with that. But the next part is dealing with essentially the same problem, but now it wants you to find the arc length of the rotation of the circle going counterclockwise. So let's go back to the circle equation. Again, the graph like will always help you out. So we already figured out, this is 1. We already figured out that the 2 points that it's pinpointing were 0, 2, and this one over here, which is radical. Oops. This is like radical 3, 1. So the first question said a counterclockwise rotation from 0, 2 to radical 3, 1. And not rotation, just like moving counterclockwise. So it's this region over here. But for this problem, it's telling you to go counterclockwise. So it's asking you to go from here all the way around and to meet it up like through the other side. Do you guys have like any idea how you would approach it?
Not really.
Natalie.
Because you're going counterclockwise, so you have to get the like opposite arc length.
Essentially, yeah.
Well, hold on. Couldn't you do like? Isn't there a way to find the total length and then just subtract it by the smaller portion?
Exactly.
Oh,
That's
okay.
exactly what you do. Do you remember what the total length of the circle is called? The total wrapping around? Circumference, exactly. So that's exactly what we're going to do. Because I don't know if there's a formula to find like the opposite arc length, but like I don't think there is, because that's exactly how Miss Q did it. And that would involve you going backwards, and like you never like to go backwards like with integrals because then it messes things up. So really what we're going to do is, in order to find the missing part, we already know this part from the previous problem. We just have to subtract this part from the total length, which is the circumference. You know that the circumference of the circle is 2 pi r. The r is 2 because the equation tells us that. So we know that the circumference is 4 pi. What we're going to do now is just subtract this portion from 4 pi, which is the whole thing. So 4 pi. So the arc length that we're finding. So remember to write s because it's still the arc length. It's 4 pi minus And now we can put that integral that we had just gotten from the previous problem. I think it was 0 to radical 3. It was a 2 over here. And I think it was 4 minus x squared dx. And that's the answer. It's that simple. You just need to like kind of think about it and like what you're trying to find. And as soon as you realize that, oh, like in order to find that arc, I guess it's really like part of a circle, but in order to find that arc, you just need to subtract the part that we had already found, or the part that's easier found like with an arc length formula. And then when you do that, again, she wants you to get the answer in the calculator. It ends up being like 10 point, remember to write 4 decimal places, 4719. And that's the answer. And that's how you would do it. So, yeah, I mean, hopefully, because that's not a problem that you'll find in the book work. But now that you've seen it, hopefully it kind of makes sense. And like, if she's gonna put that on the review, I feel like she might put a question like that on the test. So at least like now we know how to approach it.
Mhm.
So yeah, there's 14 minutes. So I guess I'll do I'll do 2 surface area problems. So I'll do the one with the 8, the one with an x's, and the one with the y's. So like there's one of each. So let's do number 8 and number 10.
Okay.
And I can send you guys like the rest of the review later. But yeah. So the next part, or this next question, is to find the surface area. So a reminder of the surface area formula first. So the surface area formula is essentially the same thing as the arc length with like a few things added. So what you add a 2 pi in the front. You keep the integral from a to b. You add something called r of x, or it can be r of y if you're dealing with like a y-axis rotation. So r of x for this one, since it's about the x-axis, times 1 plus f prime of x squared dx. And I ran out of space, but you guys get it. It's the same thing as the arc length, essentially. So 2 pi, the reason why you're doing that is because like you're revolving it around a region. So 2 pi is like 2 pi accounts for that like revolving factor. But what's r of x? So r of x is just when you have a graph, and let's say that we're plotting negative x plus 5. That's like over here, and it goes down. R of x is the distance between your graph and the axis of rotation. So r is just the equation, because the distance from that is really just the equation itself. Does that make sense?
Mm-hmm.
So yeah, that's really what r is. So just keep that in mind. It's easy, but it's something you have to plug in when you're doing the integral. Actually, no, let me only erase some parts so we can use the formula as a reference way. So the first thing I'm going to do, you don't need to graph these. You don't need to graph the arc length either. I just graphed the circle one because like it really helps you picture like what you're looking for. But really you just need to have f prime of x, and then square it. So, and this one is actually pretty simple. F prime of x in this equation, we already have f over here. That's just -1. When you square it, that's just 1. So really, what you plug in over here is just 1. So let's do the plugging in. So before I plug things in, I just like to write them at the top. So r of x is -x plus 5, and f prime of x squared is just 1. So let me erase all this stuff on the bottom, and let's write the integral. So you write 2 pi from a to b. It's from x equal to 0 and x equal to 2, so it's from 0 to 2. R of x. R of x is just -x plus 5. Let me erase this. That looks weirdly bad. And then the next thing that you do is you just plug in the f prime of x squared. So 1 plus 1 dx. There's not going to be a lot of problems that are like kind of this easy, because notice how it just becomes radical 2, and it's very easy to integrate from there. But yeah, at least for this one, it was like pretty straightforward. So this just becomes from 0 to 2, keep the negative x plus 5. This is a radical 2. Remember what I said about numbers? So remember, radical 2 looks weird, but you can just move it to the front. So this is really just 2 pi radical 2. And yeah, just like try integrating it. So Kate or Natalie, what do you get when you integrate that? Just like off the top of your head, the stuff on the inside.
Hold on.
Negative x squared over 2.
Yeah,
5x.
exactly. Yeah, it's just really then plugging it in and then doing the integral itself. So I'll do it really quickly. So erase. Okay, so when you plug it in, you get 2 pi radical 2. Remember to keep that on the outside. This is just, okay, and now it's plugging these in. So there's a 0, so we don't have to worry about that. But really, it's negative x squared over 2, which is going to be negative 2, plus 5 times x, which is 10, minus 0. Because when you plug in 0, everything becomes 0. 2 pi radical 2. This is just 8. So then your final answer is 16 pi radical 2. And that's the answer for that problem. Yeah, so it's not too bad. The hardest ones I would say are actually the surface area ones. Not this, I mean, sorry, the arc length ones, not the surface area. The surface area usually has like a little trick you can use to like get rid of it. So let's do number 10, and then that'll be like the last one for today. So number 10. And I wanted to do number 10 because number 10 it involves like the y conversion. So let's look at it. It says they want the surface area of this equation plus 2 over the interval 1, 8. So it looks pretty straightforward at first, but notice how everything is in terms of y. This is the y-axis. So this needs to be fixed, and even this needs to be fixed. You can't do 1 to 8 because the interval 1 to 8 is in x's. We want it in terms of y's. So we need to figure out the y version of this, and we need to make this in terms of x, in terms of y. So the first thing I would do is actually find the new interval. And the way you can do that is just plug in the lower bound and the higher bound, and whatever y value you get is going to be your y like range. Remember, this is a domain. We're trying to find a new range. So when you plug in 1, this becomes 1 plus 2. That's 3. So our new range is 3 to something. So when you plug in the next one, we're going to plug in 8. The cube root of 8 plus 2, that's 2 plus 2, which is 4. So our integral bounds are going to be from 3 to 4. Does that make sense?
Yeah.
All right. So now we really just need to make the new equation in terms of x, in terms of y, which means that it'll be equal to x. So the first thing that I would do is just move the 2 to the other side, of course. In order to get rid of a cube root, you just you cube it on both sides. So x ends up just being equal to y minus 2 cubed. And now this is what you're gonna be working with, and this is gonna be what you're gonna be working with. So it did involve some like conversion, but it does help you kind of get to where you need to go. So remember what you have to do. Remember the formula. And it involves like a lot of tedious side work, but keep in mind what you're actually trying to solve. 2 pi from 3 to 4 of r of y times 1 plus f of y squared dy. So r of y, remember, in previous examples, r of x was just this, so r of y is just this. So I'm going to write that down. So r of y is y minus 2 cubed. Now we need to just figure out f prime of y. So we need to take the derivative of this and then square it, of course. So it's x prime is equal to, you bring the 3 down, and then you just you subtract 1 over here. So 2. You would have to use the chain rule for this, but remember that the derivative of the y is just 1, so it's kind of irrelevant in this case. And now all we have to do is square it. So when you square x prime, you get 9 y to the 2 to the 4th. And then that's your squared of the derivative. So now that we have all those answers, I'm just gonna go plug things into the integral, and then you just have to integrate from that point. This is something you have to do by hand, and I'll guide, like, you have to look out for certain things, because there's always an easy way to integrate it, but if you get stuck on the hard way, then you're gonna be lost forever, especially on the test. So it's 2 pi. We already said it was from 3 to 4. R of y is y minus 2 cubed. Now, then we have to do the radical thing, and it's all to the dy. It's 1 plus 9 times y minus 2 to the 4th. All right, so any of you, what would you guys do next in this particular problem? Like, do you have any idea?
Wait. I don't know.
Okay, well, I'll tell you this. It is a very important thing. You know that you can just integrate this using the power rule. If the derivative inside here is on the outside. Remember that rule. So like if you have like a cosine of x, or you're doing the integral of that, you can integrate it if the derivative of the inside is on the outside. The derivative of x is 1 dx, so it's there. So that one works. For something longer like this, the derivative of what's on your inside, 1 plus 9, y, all of that has to be on the outside. So let's kind of look at that and see if we can work with that. And I'll tell you that there is going to be a way to do it, because I know that whatever the derivative of on the inside over here is, it's going to be y minus 2 to the 3rd. We have a y minus 2 to the 3rd in the front, so it's perfect. We just have to figure out the coefficient. So 1 plus y minus 2 to the 4th, y minus 2 to the 3rd dy. The derivative of the inside. When you take the derivative of this, you guys know that the 1 just becomes 0, and then you have to bring the exponent down, of course. And this is side work. You don't include it in your problem. It's like work to the side. If you can't take the derivative in your head, you move the 4 down, and then you subtract 1 from the exponent. So really, the derivative of the inside is 36 y minus 2 cubed. So keep that in mind as we're doing the rest of this problem. And let me erase all of this. So in order to integrate this using our regular power rule tricks, and the power rule, just so you guys know what I'm exactly saying, the power rule is just like when you have something on the inside and you add 1 to the exponent, so you do plus 1, and then you multiply and you divide by that number. That's like what the power rule is. So we know that the derivative has to be 36 y minus 2 cubed. All that we're missing over here is a 36. So I'm just going to write 36. But if we're multiplying by 36 on the inside, we have to have something on the outside to cancel it out, because we're kind of changing things around. So you'd have to divide by 36 here so that it's the same problem. So now, and I'll do this in green, we have pi over 18. And now we can actually integrate this. So I'm not going to write the integral sign again. What I'm going to do is just integrate it. So we have 1 plus 9 y minus 2 to the 4th to the 3 over 2 times 2 over 3, because remember you're dividing by 3 over 2, which is 2 over 3, from 3 to 4. Does that make sense so far?
Yeah.
Okay, so first thing I'm going to do, I'm going to move the 2 over 3 to the front because I don't want to deal with that when I'm doing the integral. Any number that you have that's like not within like the y's or the variables, just move it to the front and deal with it later. So pi over 18 times 2 over 3 is pi over 27 because the 2 cancels out with the 1 and it's 9 times 3, which is pi over 27. So now we have to plug it in and actually do the integral. And the reason why this one is kind of annoying is because it involves like a lot of plugging in. And notice how there's no 0 in this problem.
Yeah.
So
like
you have to do both sides, and it's gonna require like a lot of like strenuous math. Not super strenuous, but like you have to make sure like you're plugging in everything and doing it at a good pace so that you don't make a careless mistake. So let's plug it in. I always like to use brackets when I plug things in because like it's just too many parentheses. So let's plug in the 4 first. 1 plus 9. The 4 would go here, so it's 2 to the 4th. All to the 3 over 2. Remember that. Minus, let's plug in the next one. We're plugging in a 3. 1 plus, if we plug in a 3 over here, that just becomes 9 to the 4th. Yeah, I'm just gonna make sure it didn't mess anything up. Plus 9 to the 4th, all to the 3 over 2. And let me just kind of glance at my work and wait a second. Did I do it? No, I did it wrong. What did I mess up on? Sorry, guys. Oh, I know what it is. It's really 1 minus, it's really 3 minus 2 to the 4th, which is 1 to the 4th, which is really just 1. Sorry, to the 3 over 2. That's why you can't like always skip the steps, and that's why I recommend that you just plug it in and then kind of do the math yourself, because you can make a mistake like that if you just plug it in your head. I'm gonna erase all the top and then just keep working from there. So the first mission is to get everything on the inside of the parentheses as simplified as possible, so you can then do the 3 over 2 for each term. So for the 3 over 2 and the 3 over 2. Remember to keep the pi over 27 on the outside. So let's do this one first. 2 to the 4th is 2 to the 4th is 16. Yeah, it's 16. And then you have to do 16 times 9. So I know that 16 times 10 is 160. And when you subtract 116 away from that, which would be times 9, it's just 144. So that's an easy way to kind of picture it. So 1 plus 144. Because I don't know if we have a calculator for this problem. The next one, and I think I wrote 2 subtraction signs over here, so that was bad. So now the next one, it's 1 plus 3 minus 2 to the 4th is just 1. Well, 3 minus 2 is 1. To the 4th is 1. Times 9 is 9. So you have 9 over here and then to the 3 over 2 and the bracket. Next line of work. At this point, you have pi over 27. And this is really 145 to the 3 over 2 minus 10 to the 3 over 2. And we're getting close. So the final piece of work that we have to keep in mind when we're doing this is how to represent anything to the 3 over 2. So when I look at this, I actually think it's easier. This is a unique one. I think it's easier to represent it as 145 cubed squared minus 10 cubed squared. I mean, 145 cubed, the square root of that. I said squared instead of square root. And the reason why I think it's easier to represent it that way is because you can cancel something out really easily. If there's something cubed, you know that it's 145 times 145 times 145. 145 times 145 is 145 cubed. So this, squared. So this can just be represented like that. And you have an extra 145, of course. Since you have a square root, you kind of want to do everything you can to get rid of a square root. So the reasoning behind this is that you can represent the inside as 145 squared times 145 minus, and in this case it would be 10 squared times 10. And since you have something with a square inside, the square and the square root will cancel. So you can write this, and this is like how she wrote her answer. You can write it as pi over 27. This will cancel out. Remember, there's still going to be a radical for that term. So it's going to be 145 radical 145 minus 10 radical 10. And that's the answer. Did that all make sense?
Yeah.
Okay. Yeah, so that's like the last problem that I'll do today. But yeah, thank you. I'm gonna stop the recording.